In this example, we're going to learn how to multiply rational expressions, and specifically the denominators will be different in this example. Not that it makes too big of a difference, but it just gives us more polynomials to factor. So for my first polynomial here, the numerator y squared minus 2y plus 1, it's all divided by y squared minus 1. And that rational expression is multiplied by 2y squared plus y minus 1, divided by 5y minus 5. So the first thing we want to do to multiply these together is to factor every polynomial that we can. So I have the first expression here, y squared minus 2y plus 1. So I know I'm going to need two sets of parentheses, so I'll set those up. And then I'll need to figure out what times what makes positive 1, but then adds to be negative 2. So I'm thinking that negative 1 and negative 1 are going to work. And then I'll put a y at the beginning of each parenthesis because of the y squared. And I can just quickly check that. So the outside terms, y times negative 1, that's a negative y. Inside terms, negative 1 times y, that's another negative y, so that's two negative y's. And then the last terms, negative 1 times negative 1 is positive 1. So we're good. For the denominator, I notice that I have a difference of squares. There's y squared, which is a perfect square, and then negative 1 is also a perfect square, because 1 times 1 is 1. So the convenient way to factor that is y minus 1, and then set parentheses, and then I have a y plus 1. So same numbers at the beginning and end, and then one's negative, one's positive. So on to the second rational expression. I'll write down my fraction bar. I'll need to have my two sets of parentheses. There we go. So looking at this first term, 2y squared, so what times what makes 2y squared? I know I'll need a 2y and then a y. It doesn't matter which set of parentheses gets the 2, but one of them needs to have 2y. The other one has a y. And then the last term I notice is a 1. And I know that only a 1 times a 1 can make a 1. So there's going to be a 1 at the end of each set of parentheses. Now what I don't know is the sign in the middle. So the middle term of this polynomial is positive y. So if I do a little scratch work, let's say I had a plus and a minus in my parentheses, and I do some just checking. 2y times negative 1, so that's a minus 2y. And then the other middle term comes from the inner, so I just did the outer, I'll do the inner now. 1 times y, that's a positive y. And if I add those together, I get, so negative 2y plus 1y is a negative y. That is not the middle term inside my polynomial. So that means that my plus and minus signs are incorrect. I'm going to go through and erase them. And now I'm going to switch the order. So at first it was minus, let's get a different color here. We had a plus minus, so I'll do a minus plus. And now I'll check. 2y times 1, that's a positive 2y. Negative 1 times y, that's a minus y. So 2 y's minus a y gives me a positive y answer, which is my middle term. So that means that I have factored correctly. The order of my signs needs to be negative, positive. All right, and on to the last denominator, 5y minus 5. I notice that 5 is the greatest common factor, so I will factor out 5 from both terms. That leaves me with a y in the first term. And then when I factor out a positive 5, I'm going to circle this right here. So this negative 5 here, when I factor out a positive 5, it leaves me with a negative 1 left over. You can also check this by foiling, or distributing, because it's so small. 5 times y makes 5y. 5 times -1 is -5. Okay, so I have factored all four polynomials, and then I can put all of these factors into one giant fraction bar because all of this is multiplication. It's just been grouped. Here we have this groups multiplying and dividing. Here's another group multiplying and dividing. But I can just squish everything all together onto one big fraction bar because it's all multiplication. All right, so everything's with one fraction bar. Now I can continue this problem by canceling out any factors that I see similar to the numerator as well as the denominator. So the reason why we get to do this is, let's say I'd group these guys together here, these y minus 1s. Well, it's kind of like a fraction, but they're like slid over a little bit. Y minus 1 divided by a y minus 1 is the same thing over itself. Y minus 1 divided by a y minus 1 is anything over itself is always a 1. So when I see a similar factor on the top and the bottom of the fraction bar, I get to cross them out because they have really turned into a 1. So I'm going to put a little 1 right there just to remind myself that they didn't just disappear, they turned into a 1. So I'll look for anything else like that in this fraction as well. So it looks like here's a y plus 1 on the numerator and a y plus 1 on the denominator. So those cancel out to equal 1. And let's see, here's a y minus 1, and here's a y minus 1. So those will cancel out the entire group there to be a 1. Now it doesn't actually matter which y minus 1 I'm dealing with. Like I could have canceled the first factor on the numerator and denominator because they were the same, but for some reason I just didn't see that first and I saw the second one. Doesn't matter, they're the same factors, so as long as they're getting canceled out, we're just fine. So let's see, anything else? There's a 2y minus 1 on the numerator, and there's nothing like that on the denominator, and then we ran out of factors. On the denominator there's a 5, and there's not a single 5 up here on the numerator, so that means we're done. We have an answer of 2y minus 1 divided by 5. So we have just multiplied two rational expressions by factoring first, simplifying, and then writing down our simplified answer.